Okay, so we're going to look at what is a structure for a ski glove, a heated ski glove. So essentially this is the glove ripped open, and this is the inner lining, so that's what you put your hand in. So everything is made inside out, and then it's made the right way for assembly. So everything's essentially made the right way round. Sorry, the other way round. This is your inner lining, which is almost just like a very thin polyester and with a soft feel, and it's got this kind of wadding back to it, which is extremely cheap, and it's bonded either with heat or a thin layer of glue, and that's on both sides. There's nothing else on the inner lining really at all. You can understand why some of the cost is quite high for the stitch work for the fingers. There's a lot of stitch work there. Most of the assembly cost is going to be associated with that for both halves as well. This is the outer side with the same wadding, and I've split the outer just so you can see. There's the button here. It's only got one button, and there's a pocket which is on the top side. You've got a zipper there. It's not even waterproof, it's just a standard zipper, and that'll be a number, what number will that be? That'll be a number 5. There's a number 5 zipper. It's probably the most common and cheapest. You've got two types of a number 5. There's a big 5 and a small 5. So that's the small 5. And you've got a standard zipper. It's not even waterproof. Some of the hole work here. This is where the wire which goes to the main PCB slots through. That's not even finished. That can actually just rip. I'm surprised by some of the finish here. So that is the outer. There's the button there. It's a very common button. You press it 3 times or whatever, and it has different functions. The pressing is controlled by the PCB, which we'll have a look at shortly. This is just this exits the main PCB, and that connects to your batteries. That goes through this sort of stamped hole, and it's accessible through the pocket. And that is where you're putting your battery, inside there. So it's on the top of the wrist. Now, this is where the real work starts. This is quite a good quality glove because they're using what's called composite filament. What's that? Well, it's not really clear what it is, but the difference is that the filament and its joining wire is actually the same. So the filament, which you can just about see there, is the adjoining wire but stripped. And then this black part is essentially die-cut non-woven polypropylene sheet. It's extremely cheap. It can be die-cut very easily, and it's got a similar backing to it. Now this filament is actually stitched to this, so it's not woven and glued and pressed, it's just stitched. You can see that because you'll see there's some silver woven into the, if you look closely you'll see the silver shining. That is the filament stitched to this polypropylene. And the filament this is actually not fixed. Yes, it's actually just fixed at the fingertips. So for an elastic glove, a glove which will stretch to different hand sizes, we want to fix its base at one point. In fact, we want to fix it, but almost not pull it tight. So here you've got a small arch, and that would, with that remaining, it would allow the glove to stretch in its length. Its width would be no problem, but its length will also be no problem. Filament can't really move itself. It doesn't move, it doesn't stretch, especially this composite type, which is a lot more safe in its operation. So that's essentially the heating part, and this is just supplied from a separate factory to the glove factory because it's fairly cheap. It's fairly standard technology. There's no thermostat on here. Let's call it a thermistor, which is as common as an NTC type. There's none here. would actually be a little bit more expensive to embed that on this process. It would, because this is probably just automated. Adding a thermistor here would add more labor cost. So then we come to the guts of the product, the MCU, the PCB. So here's the exit wire for going to batteries. So that's this side, and this is the input from the filament. This has been disassembled, so I've essentially ripped this open. This PCB was mounted inside here, and it was potted with silicon, and then it had this backing over it. And the border to it is fabric, and that is actually just a molded button. So you see this side of it's a little bit shiny, and on the other side we'll see the button. This is a standard part. So here we've got the top of the fabric is with a square opening which has been finished with seam work, and that seam work stitches into the border to which this button is mounted into. So it's compressed between these two sides by this small fabric assembly. This feels like PVC to me. So that's how the button fits in, and this is a very common button you can buy from the market. It's really not special, so it's not owned by this company at all. Then we come to the PCB. So this is a standard surface mount PCB. We've got a push button which is mounted to the PCB, and when that's mounted in here, there's a small, which I've lost, a small clear PVC square which is mounted in here first, and then the PCB goes in, and then it's potted. So when you press that button, it divides more pressure. It feels like you're pressing a more solid button rather than just the tip. And on the other side, I've got two chips and some power control. So this is your main MCU, and that'll be controlling what the press 1, press 2, press 3, etc, etc. We've got 4 LEDs, so they're your different power settings. Rather than having a tricolour or bicolour 2 LEDs, they've gone for separate LEDs, and they will be, they will be dirt cheap. You can go for the lowest quality LEDs because the brightness is fairly low, and the amount of hours that they're constantly on is well below the 100,000 common for LEDs, so they will be the cheapest LEDs possible. The other reason they've potted this inside here with silicon is so the wires won't pull off too easily. I'm surprised they haven't used some sort of a connector there, because that would speed up the process. I can't see a thermistor on here. You can have standard NTC surface mount thermistors which are on the bottom side. This is a double-sided PCB, so you could easily place a thermistor on the other side. I'm not sure if that's one. I think that might be a thermistor there, although I'm not sure. But there's easily space here for a thermistor on either of the corners of this PCB. So that really is it in terms of, I'm quite surprised how rudimentary and basic that really is. I'm surprised by some of the poor quality aspects of this. There's really some factors in it which are really very cheap. Right, there we go.